Become a supporter for my Patreon to get access to all my tutorial project files, including the one you're watching right now. Welcome back to the channel. In this video, we're going to be making an advanced NPC system where we'll be able to make enemy NPCs, and the NPCs that we'll make will be able to pathfind to the enemies, and they'll be able to raycast to see if there's enemies near them. They'll be able to choose the best target for them, and the system will also allow us to make a bunch of different NPCs that we want. If we want to have like custom attacks and things for the different NPCs, we can do that. I want to make this a series because we can do a lot with this system, but in this episode I'm only going to be making a fighter that's just going to kick and punch you, because this is going to be a lot of scripting for making the main system. But first, to get started, we're going to need to add a main module script into server storage. We're going to call this NPC, and this is going to be the main logic that most of our NPCs are going to have for like moving around and deciding who to attack. But then, because we're going to want to have different types of NPCs, we're going to have a folder called NPCs, and then in that will be another module script, and this is going to be our Fighter NPC. So I'm going to call him Fighter, and we're going to kind of set up our Fighter NPC just a little bit and make a model and stuff for him. So we'll have someone to test out and see how it works. So right here, I have just a simple R6 model, and I will leave this in the description, but all it is I just went to Avatar, I went to Rig Builder, got an R6 model, and then just did a block avatar, and I colored him a little bit. I turned his local animate script into a server-side script and just deleted some unnecessary code in there. However, your model is going to be, make sure that you have an animation kick and an animation punch that's going to be inside their animator, which is inside the humanoid, because this guy is going to be able to punch and kick people, and so we're just going to store those two animations inside of here. And I don't know if my animations will work in your game. They might work in Studio, but if you try publishing your game and you use the same animations as me, I don't think it will work, because I'm like the owner of them, and I don't think Roblox lets you use animations that you don't technically own. But what these animations are, if I go to my animation editor, and so for animating the model, if you have different attacks and stuff for like the kick and the punch, this is the kick animation that I've made. So he does something like that. And you can make it look however you want, I just did a kick, but we want to figure out when the user needs to inflict damage. So right about here, like when he's like kicking, is when we want to see if there's anyone around you and do damage to them. And what you're going to do is in your animation editor, I have this animation event, which you can right click, and then you can add an animation event. And that's what I've done right here, is right on this keyframe when he's like kicking, I've just added an animation event, and I've called it hit with a lowercase. And I've also done the same for the punch animation. If we load it up, this is what it looks like, just a punch. But right when he's like actually doing the punching and hits, I just made sure to put that animation event, and you can move it around and stuff. But that's what I've done for my animations, and that's what's going to work for the way I'm scripting this guy. And if you have made an animation, do make sure just to set its animation priority to action 1 or just action. This will just make sure that it overrides any like movement. If he's like having some idle animation or something, this will just play over that, so we can see him like actually punching or kicking. But with those animations made and published and put inside of the animator, we're going to take our fight model and we're going to put him inside of our fighter module script. So this script will be able to use it later and use him as the model. What we're going to do first is work on our main NPC script, and this is going to handle like the logic and the creation of our different NPCs. So what we do in this code is we create a new table called self, and we want to set the meta table of this table to be equal to the NPC class table. So this might look a little confusing, but basically what we're doing is we're just making a new table like this and then setting the meta table of self to NPC class. This is just a cleaner way of doing it. And when NPC class is our meta table of self, if let's just say we try to access something like self.name, and self.name isn't going to equal anything because this is an empty table. And we're going to see that NPC class is the meta table, and that __ index is set to itself. So it'll check to see if name is inside of NPC class instead of this empty table. So if we were to do something like NPC class.name equals this is the name, then any new tables that we make, so we can make like 1,000,000 new tables, and we can set their meta table to NPC class. And if we do that, then all of these tables, even though they don't have an item called name inside of them, it'll just go back and look to see if it is in here instead of here, and we'll be able to print that out. And by doing this, we're going to be able to create a bunch of NPC classes, which will all be able to use the same functions, and this will basically stop us from using a bunch of copying and pasting in a bunch of different scripts. We can just put it inside of one big script, and all of the different NPCs will be able to use all the same functions. And so after making our table, setting the meta table to our NPC class, then we're going to be able to add data to our class. So we'll be able to quickly access the model, the root, and the humanoid. And we're going to get our model by accessing the args.model clone. So we're going to get our arguments from our fighter model. So our fighter model, we're going to make it a little later. It's going to run this new function with some arguments like what the model is going to look like. And then we're just going to set the root to the model.humanoid root part, and then also the humanoid, just so we can access like health and certain things really quickly by only just doing self.root. And to keep it really simple, after we've made our model and given it some data, we can just spawn it by doing self.model.parent is equal to args.parent, so wherever we want it to be spawned, and then also the spawn C frame. And we also want to make sure to set the network owner of our root to nil, so this will handle it through the server side, so it won't make it as laggy when the NPC is moving around and chasing different people. But this right here is a really simple way that we've made our NPC class and spawned it in. We just need our fighter model to call it and to give us the model argument and the parent argument and other things, so we know what to do with this NPC that we're spawning in. And starting with our fighter script, we're going to require our base NPC class, which is this right here, and we're requiring that from server storage. And then we're also going to set the meta table of our main module script to be the basic NPC. So if this fighter NPC is trying to move somewhere, we'll have the function stored in here instead of having a move function stored in every type of NPC in our game. The reason we're making this a separate module script instead of just keeping all the NPCs in here, because our fighter will have different attacks and have different things than other NPCs might have. So our fighter script will be able to use the same movement functions, but attacking and stuff will be handled in this script. But then anytime a new fighter is being created with some arguments, we're just going to base npc.new with our arguments, and that's going to give us self because we return it right here. And once we return that, we're going to reset the meta table to the fighter class, because the fighter is going to have more specific functions and attack things that the NPC is not going to have. So it will be able to use functions that are inside of this NPC class because of this right here. But by doing this, we're also allowing any other functions that we make inside of here to be used by this fighter NPC, and only the fighter NPC. And we just want to make sure that there is a default for all of the arguments that a script could give us. So if they didn't give us a model or a parent, then we're just going to default that to our fighter model or workspace. But if a script was wanting to give us like a special looking fighter or something, then it would be overwritten by this. And so with the very base of this being set up, we actually can now spawn in an NPC, and also make sure that you're returning the fighter. I didn't do that, but you want to return that fighter class. So if the script that is creating this new fighter wants to change some things about it or look at the name and things, it can do that. But inside of this server script that I've placed inside of server script service, I've required our fighter NPC, and now we can spawn him by simply just doing fighter spawner.new. And then we do need to give him a table with all the different arguments, and we do need to give him a spawn C frame. So I'm just going to do that, and I'm going to equal it to workspace.spawnlocation.cframe. So that's going to spawn him exactly where the spawn location is. And if I wanted to give him a different model or parent him to something else, I could add that here, but we're just going to only give the spawn C frame. And if I were to run my game, I could play right here, and we would see a fighter model spawn right in. He doesn't do anything, he's just chilling and just waiting because there was really nothing about him. We can print some info about him if we would like. So we can do our new fighter is equal to this guy, and if we want to just print maybe his name, and I can actually change that right here. So inside of here, before we return it back to the script, if we want to say something like self.name is equal to buddy, and then if we wanted to do self.model.name equals self.name, that would also change the name of the model because we set the model right here. But with that, we can do our new fighter, and I'm just going to print his name. Actually, we'll do print new fighter dot name, and then just say is the name. We'll play it right here. It says buddy is the name, and it also says buddy because we changed the name of the model right here. But this is the start of how our classes are going to work, and you can see that we can add any data that we would like, which is going to be really helpful. We can add functions, we can add just strings if we want. but we'll be able to add a bunch of different stuff which will make our NPCs really cool. Now our first method I'm going to make is it's going to be an attack method that's just going to be the default for all of our NPCs, and it's supposed to get overwritten by whatever NPC is using it, but we'll just set it default for now. So it's going to be new class with a colon attack. We're going to say warn NPC tried to attack, but no attack was set. So if with our new NPC class that we create instead of here, or our fighter class, if we try to attack, it's going to, well, we also can delete that because we deleted the name thing. But if we try to attack with our new fighter, it's going to try to access it inside of this table, see that it doesn't exist, look inside of this fighter class, see that it doesn't exist, and then the fighter class is going to look inside of the base NPC, and because it exists, it's just going to run the function and say that. So if I go right in, we'll wait 3 seconds, and then it says NPC tried to attack, but no attack was set. But because our fighter is going to have special attacks, we'll be able to easily overwrite this. So I can kind of just copy this, go into our fighter class, and replace this with our fighter class. And now any fighter that tries to use the attack method, it will run this instead. So I'll just do something like, we'll just print fighter has used an attack, and we'll make our attacks later, but this is just to show you how the system works and how we're able to create different NPCs and with different attacks and stuff. So we'll go in and it says that the fighter has used an attack because it first checked inside of here, didn't find it, checked inside of this script, and it did find it. And so our first class that's going to run is our NPC class Logic, and what this logic is, it's going to, while true do, and we're going to try to find a target using the method find target, which we need to create, which I have not made yet. If there's a target, we're going to decide what to do with them, but if not, then we're just going to wait until there's another target. And I have this variable right here, update tick, which I'm going to add this right up here because it's just how often you want the NPC like looking for targets or how fast things update. So I'll just do update tick, and I'll equal that to like 0.2, which is pretty good, but you can speed it up or slow it down if you want. But we need to make our find target method so that the NPC will actually be able to find a target. And so before we create this find target method, there's going to be a few methods that we need to make, which is our isTargetAlive and distance2. Our isTargetAlive just takes an argument for whatever target we're wanting to know if it's alive, and we just make sure that it is alive by checking that it's not null and that it has a humanoid root part, that it has a humanoid, which actually should be find first child humanoid, and if there is a humanoid, and the target's humanoid health is greater than 0, so it's not dead. And if it is not dead, then we'll just return that result. Okay, the second method is NPC class. It's just to_distance, or the next method is NPC class distance2, which is just how far our NPC is from whatever position that we give it, which is really, it's just a simple line of code, but I'm just replacing it so it reads out better, because instead of saying if this is greater than like 15 studs, it's just easier to say if self distance 2 and then some position is greater than 15 studs, or whatever example we might have. But that's all it does, is it just gets the distance by having our position and then the position that we give it and then the magnitude. And to start off our find target method, we get all the players in our game, because right now for just the first episode, we're only going to make it where they attack players, which we can definitely make it where they attack other NPCs. But for now, they're just going to be attacking other players, and we're going to have a table called in-range targets, which is going to be just an empty table. And we're going to go through each player in our players table, make sure that they have a character, and if they don't, then we're just going to continue. And then with our isTargetAlive method, we can just check to see if self, but we check to see if the target is alive, giving it this character. And if that's equal to false, then we continue, because we don't want to be chasing after dead people. And then after we have a possibly valid target, we want to get the distance of that target, so we use self distance2 and then their humanoid root part dot position. And if their distance is less than our self dot vision, which we've not created the vision of the NPC yet, so we can actually do that right now. In our NPC, we can just make the default vision, so I'll just do defaults, and we'll do self dot vision is equal to 100 studs, and we can modify this in the fighter class if we want. So if we want the fighter to be a little better at vision, we could just do their vision is equal to 150, but for the basic NPC it's just 100. But after we have our vision set, we can go down to here And if the distance from our target is less or equal to our vision, so we can see them, then we're going to need to insert into our in-range targets table a table which has two keys in it, char and distance. And char is just going to be equal to the character, and dist is just going to be equal to the distance to our target. And we do this so we can sort them by who is the closest and who is the furthest. And once we have a table of all of our in-range targets, we want to make sure that that table is not equal to 0. But if it is, then we're just going to print that no targets were in range and just return nothing, telling that we did not find a target. And if there is at least one target or more, we want to make sure that we sort the table. So we're going to use table.sort, give it our table that we want to sort, and a function for how we want to sort our items. And we want to order it where the first items in our list have a lesser distance than the last items in our list. So it'll be the closest players first that we will attack. And what we've made right here is the self.main thread, which is going to equal a coroutine, which is going to handle how our logic gets ran. How we do that is we run our logic, but we do it inside of a p call. So if there's an error that happens, it will catch it and it will run this function, which is called debug.traceback. And it's just going to basically tell us where the error happened. And we're also going to do if this failed to run, this will either be true or false. But if it failed to run, we're going to warn that we encountered an error with our error message. And we're basically putting all of this inside of our self.main thread, so we can control whether the NPC is running or not. And we have our logic right here, and we also have our find target. And make sure also that you're returning the in-range targets with the index of 1 and then the character, so that we return the nearest character. But with that, we can have our logic set up because we're going to find our nearest target. If there is a target, we're going to chase them. And with all of this set up, once we return self, we can go into our fighter and we can just do coroutine.resume self.main thread. So all of this will start running. So we can actually test it out, and we can see that this is going to run, and it's going to say that our logic has began. It's going to see if we have a target or not, and we can just print that right here. We can say target found, and then we can just put our target. But if there was no target, we'll just put that we are still waiting for a target, and we can play it. We can look at the output, and we'll see that target has been found, cozy coin. And that's just kind of our basic logic right now. He doesn't do anything. He's just going to keep running at me because that's all we've set him to do. But we can also test out our error catcher to see if there is, to see what happens when an error does happen. So if I try to access something like humanoid, I just do something like that. We'll go and it runs. It'll say we encountered an error and attempt to index nil with move to. So the next thing we're going to fix is that they will not be able to find a target unless they can see the target. Because you can see right here, I put a wall right here, and our NPC should not be able to see us. But if I play, he's going to think that we're right here, and he's just going to run right into this wall, thinking that we are here and able to be seen in calc. So we're going to use raycasting, so he'll be able to actually know if he can see us or not. So we're going to make a method called canSee, but before we can do that, we need to set up some raycast params because we're going to be using raycasting. So in our class, we give raycast params, which is just going to equal raycast params.new. And we want to set this params filter type to be enum.raycast filter type.exclude. So it will exclude whatever is in the filter descendants instances, this right here. So once we set this to be our self.model, then it will ignore our model. So we won't be able to raycast and accidentally hit our own character. And then we also set respect can collide to true, just so we can see through things that are set to can collide false. So to start off making our canSee method, we have the argument of the target. We have the origin, which is our self.model.head.position, because that's where it's going to start from. Then we have our direction, which this is where the beam needs to be pointed and for how long it's going to go in that direction. So we take the target humanoid root part.position and minus it by our origin, and then we get the unit of that and then times it by how far we want this beam to travel. So we do it by our vision because that's how long the NPC can see for. And then we actually do our raycast by putting it in a variable, doing workspace, raycast, giving it our origin, direction, and then our self.raycast params. And so we just check to see if our raycast was a success by checking if we had a raycast, and if the raycast.instance.parent is equal to the target that we were looking for. And if that's true, then we just return true, saying that we can't see the target. If that didn't happen, then we return false because we can't see the target. And if you would like, in the description, there is a model to a module script called Npc Visualizer, which I'm going to use in this tutorial. That all it does is I just made it so it visualizes the raycasts and the waypoints when we're pathfinding. It's not necessary to the end result. It just shows you what the NPC is seeing and where he's going to, which can make it helpful for debugging. So I just wanted to include it. And if you want to use it, go to the toolbox, get the model, and then you'll see NPC Visualizer. Put it inside the NPC, go to your NPC, and then at the very top, I'm just going to go to local visualizer is equal to script, wait for child, NPC visualizer, and we also need to make sure that we are requiring this. And with this, you can see that inside our NPC visualizer, we have .ray and .waypoints with a few arguments that are needed for making it visual. And we're going to just do, what we're going to do is we're going to take this, and wherever we want, when we want to visualize a raycast or something, we can just do that. So I'm going to do visualizer.ray, and we need to give it self. We need to give it our raycast, our origin, and our direction. And with that, then we'll have a visual representation of our ray. And if you are using it, you'll notice that if you look inside, that we check to see if our self has a debug enabled or not. And this is so we can easily turn off any visualizations by just turning on and off a debug variable. So we can actually just, right before we run our NPC, we can do self.debug is equal to true. So then it will run these, but if we don't want to run these when we're having a real game going, we can just do false and it won't have the visualizations anymore. And now that we have a way to figure out who's actually in our site, we want to go through all of our target data that we've made before in our find target method. And we're going to go through each one, and we're going to do self can see onto the target data .character. And this will show if we can actually see the people that are in our range. And we're going to keep going through the table closest to furthest. And the first target that is visible, we're just going to return that target. And because now that we have this, we don't need to return this anymore. And if we want, we can just instead print no targets were found. So we can actually test this out now. I'll put that wall back again so our NPC will not be able to see us, and we'll also be able to see the visualization of the raycast. But I'm going to go here, he's going to spawn in, and it's going to show that he's trying to see, but that little white point is where it's getting blocked. So he keeps on raycasting to me, and it's a little bit behind me, but that's only because the server takes a little bit to update. So that's where I really am for everyone else. But you can see that he's just trying to look at me. He can't find me. But if I just peek out enough, he's going to start chasing me. And if I hide again, he's just going to keep walking to that point, and he's going to keep following me. And you can see that if he does see me and follows me, but I manage to get around a corner and go right here, he's going to walk to the last point he saw me, but he's just going to wait until he can see another target again, and then he'll keep chasing me. So the last thing we're going to add to our find target method is we're going to find the closest player like we do, and if we can see them, we're going to check to see if the distance to the target is less than our area, and we're going to need to add this area as a variable in our class. So we're just going to do self.area, and I made it equal to 10, but with that area, we check to see if they're in the area, and then we attack, and we also give them a little bit of a buffer by timesing the area by 0.55, so the NPC won't attack unless they're a little closer than what their area is, so the user won't run out of the area when they're attacking. And you can change this buffer to fit your game depending on what NPCs you have, but I found this to just be good with the fighter. So I can start it up again, and we'll see that the NPC is going to see us, and then it's going to print that the NPC has attacked us. You can see the fighter has used an attack, but all our attack does is print, so that's all he's going to do. He's just going to print and keep chasing us. And before we continue with making the NPC, things are going to get a little complicated with debugging and trying to print things out. And if we have multiple NPCs, we're going to have a lot of prints going on. So we're going to try to simplify this by making a debug method. And this method is going to see if we have debug enabled. And if we do, then we're going to get the source and the line. And that's what these two characters do for the function that called this method. And then with our source and the line, we're going to print out a few things. We're going to print out a table that is going to have our self, so we can look at the data that's in our class. And then I just put some brackets with a colon and more brackets saying the source and the line. And then that table is going to be its own little thing. And then we're just doing a dash with all of the other stuff that was wanting to be printed. So basically the real message. So we can test this out. I'm just going to replace some of our prints that we have with our new debug method. So instead of logic for self has began, we can do self debug logic began, something like that, and we can just replace a few others. So I just did these, and I'm going to replace the rest too. But just to show you, we're going to play our game, and you're going to see, if I go right here, it'll say logic began. And if we want to see data about the NPC, we can open this up. We can see that it happened on the line 64 of NPC, which if we look right here, that's when it happened. So we can find it. And then also we can see data about ourselves. So we can see our area, the humanoid, what route we have, just kind of locate it in the workspace if we want. Just makes it easier for finding what NPC printed it out. And you can see that I still need to replace some of the prints that we have. And so with our new debug method, I've replaced all the prints with our debug, but I have kept this as a warn because this should not be turned off. We shouldn't be able to silence these. We should be able to see if there's an error or something. And I also just switched this from a warn to an error. If this attack were to happen without the NPC having an attack, then it would just go back to here and it would trigger this. But now that we have all that set up, we can turn our debug to false and our NPC will do everything as he normally did, except there won't be any prints and there won't be any raycasts. So he's just a normal NPC. We don't get to see everything that he's thinking, but he just does and acts like he normally would. But let's say we were to have two NPCs in our game. So if I just copied this and I'll call him new fighter 2, and if this new fighter, I could do new fighter 2 dot debug is equal to true. So our new fighter would actually have debug, but the first one wouldn't. So we can test it out, spawn them in. We can see that one of them has debug on and the other one doesn't. This is really helpful for just debugging certain specific NPCs if you need. And now we're going to change the way our NPC chases the targets a little bit by making a new method called chase. And this is going to replace the way that we've been chasing them. Instead of just walking to them and repeating this, what we're going to do if we find a target is we're going to chase to that target. And we'll be able to do a lot more in this method and not have to put it inside of this if statement. But what we do is we create a new loop with our update tick, and we check to see if the target that we're chasing is still alive. And if they're not, we're just going to return and go back to our logic and try to find a new target. But if they are still alive, we're just going to chase them for now. And so we've added some new code in between these two things, but what we do is we try to find if there is any new targets or if we can still see our same target. So we have seen target, which is equal to ourself and finding a target. And if we don't have a seen target, that means there's no available targets, even the one that we were chasing. So we're going to return, and then we're going to also run our pathfind 2, which we have not made yet, but this is going to pathfind to our target. So we will make this, but this is what's going to happen if we can't see our target. But if we can't see our target, but this seen target is not equal to the target that we've been chasing, then that means we found a closer or a just better, easier target. So we're going to debug and say that chasing easier target, and we're going to chase that new target while returning. And this is the starting of our pathfind 2 method. It's going to take a argument target and our argument attempts, and this argument is going to stop us from trying to calculate a path that is impossible too many times. But we're going to have our start point and our destination point. The destination is just the target humanoid root part dot position. Our start position is our position plus our movement direction times 13. I do this because sometimes the NPC will kind of be a bit glitchy. He'll be walking to the target, decide that he needs to pathfind to the target, and then walk back to a waypoint and then continue along the path. So he just like kind of stutters. So I did this just so the path will calculate ahead of where he's walking instead of the calculation happening behind him. So he's just a little bit smoother. But we actually create our path by making a local variable, and we use pathfinding service, which we need to add to the top of our script. So right here, I'll do local pathfinding service equals game gets service pathfinding service. So we get the pathfinding service. We create our path with our parameters, and then we need to compute the path by using compute async, giving it the start and the end destination. And now this is how we're going to keep our NPC in check if he's trying to calculate to an impossible position. We check to see if the path status is not equal to success. And if it isn't equal to success, we're going to get our attempts variable, which could equal nothing. And if it is, we're just going to default it to 0. But then we're going to plus it by 1. And if the attempts to calculate to this destination has failed more than 3 times, then we're just going to return and go back to our logic. But if it hasn't, we're just going to debug that our path has failed however many times. And then we'll return with our new attempts and the same target, trying to recalculate to them. Now, if we have successfully calculated to the destination, we just need to get all of our waypoints by using path get waypoints. And then we also have a variable for our last waypoint, and that is just going to equal all of our waypoints, but then we get the number of how many waypoints we have. So basically, we're just going to get the last waypoint in our waypoints table. And we're going to visualize our waypoints by using our visualizer.waypoints, giving us the self and the all waypoints variable. So then we can see what the NPC is thinking and where he's trying to go. Now that we got the waypoints, we just need to follow all of them. And now that we have the waypoints, we just need to follow the path. So we go through our all waypoints table with our waypoint, and we're going to move to our waypoint by using our move to with the waypoint dot position. And we need to make sure that our NPC successfully moved to the waypoint by having a moved variable, which is going to be our humanoid dot move to finish, and we're just going to wait. And if this does fail, then this will return as like a nil or false value. And so if we did not successfully move to the point, then we're going to debug saying that the move to waypoint failed, and then we're going to just repathfind to the target. So if we're walking along the path and we see someone in our vision, then we're just going to return with our chase method to that new target because we can chase them. So I'm going to go ahead and test this out, and I'm going to turn on debug to be true so we can see where the pathfinding points are being placed and all of that. So I'll go in, and I'll be behind the wall right now. Won't be able to see me. I'm seen. They're going to chase me, but oh, I'm out of vision, so now they got to chase me, and oh, there I am. They're going to keep following me. And yeah, I can just kind of keep doing this, running away, and they're going to keep following me. So this works pretty good if you're on flat ground, but as soon as we add terrain, things can get a little bit messed up. So I'm going to spawn in. He's going to see me. He's going to chase me. Oh, look, he's got a pathfind to me. But then wait, he can see me again. And so he's going to just try to chase me. And wait, then he can't see me because he keeps hitting the wall. So he's just going to keep running back and forth. So if your game only includes flat grounds with maybe just walls that the NPC needs to pathfind around, then what we have right now is pretty good. But if you have terrain like I've made here, where the user could possibly be up on a platform while the NPC can see them, then this next part we're going to make is going to help with that. To fix this issue, we're going to be creating a new method called shouldPathfind. And what this is going to do is it's going to tell the NPC if they should pathfind or chase the target. And how we're going to determine if the NPC should chase or pathfind to the target is we're going to have two raycasts. One is going to shoot down from the NPC, and one is going to shoot down from the target. And we're going to see basically if there's anything under them, and we're going to hopefully try to hit the floor. And if we hit the floor and the height difference between those two positions is greater than a certain amount, then we're going to know, okay, this user or the NPC is like too high up, and we should just pathfind to them instead. So we're going to first raycast for ourselves and see if there's any floor underneath us and try to see where we are. So we're going to have our self down direction, which is just going to be a vector 3 with the minus of this data right here, which is going to be max step height, which we need to create in our class. So I'm going to bring this up here, and I'll put it under where we do raycasting. And it's just going to equal our self.humanoid.max jump height, and then also +4. If you see the NPC model, we're going to be shooting directly from the center of the humanoid root part, so it's going to be whatever their jump height is plus 4 studs. So 4 studs might not even be enough. Maybe it is, but you can increase it or decrease it depending on what NPC you're using, and obviously if you need to override it in here for your different NPCs. And I'm also using jump height and not jump power, because in starter player over here it says character use jump power. That is not selected, so I'm using jump height instead. But if you're using jump power, I recommend using jump height because it's easier to see how many studs they're jumping up than just a random power value. And that's what we're going to use down here. So we're going to be shooting down by that many studs. And we're also going to get our self position, and then we're going to raycast by just workspace : raycast, and we're going to give our self position, our down direction, and our raycast params, and we're also going to visualize it. And now we got a raycast for the target. So we're going to make some new parameters for our raycast. And it's going to be pretty simple. It's just raycast params, doing kind of what we did with the NPC, setting the filter descendants to our target, and then setting the filter type to be enum.raycast.filtertype.exclude. And forgot target params dot respect can collide, make that equal to true, just so if they're walking over a non-collidable object. But that should be good for our parameters. And then we're gonna have something similar to what this is gonna be, but for the target, our target max drop. So this is the farthest we're gonna allow them to drop. And I just did 11 studs, which seems to be good for our characters. Change it for if you have custom characters or if they're able to jump really high or something, you can change that here. And then we also have our target down direction, which is just our direction that's pointing down, and it's going to shoot by this many studs. And then we also have our target position, and with that info we can raycast on the workspace and just give it our info. And then we also visualize it so we can see if the target is hitting anything or not. Quick mistake I made, I said max jump height. It's just jump height because that's what it says in there. I just thought it was max for some reason because we put max here, I guess. And another mistake I also made is when we're using the visualizer.ray, I put our self ray and then down direction and then raycast params for some reason. That's not really what it's supposed to be. It's supposed to be the origin right here, so it'd be self pose and then our direction, and then that will actually visualize what the ray looks like. But I really want to show you guys what the raycasts are going to look like, and that we can see that the raycasts are happening to our target and to the NPC. So I'm just going to run the method, not put it in any if statement because it's not ready yet, but just so we can see the raycasts. I'm going to run the method in our chase method. So right before we move to our target, we just run this just so the raycasts happen. And I just changed the map a little bit, but you can see that as we are being chased, there's a raycast under me and there's a raycast under him. But we can also see that if there is nothing under me, it's going to shoot red because we're not under anything. So the first check we're going to make to see if we need to be pathfinding or not is if both of the raycasts are existing and if they hit something. And if one of them didn't hit anything, then we're going to say raycasts failed, path needed, and we'll just return true that we need to pathfind to them. And the next check we're going to make is to see if the floor underneath them, if the height difference is too much. So we get our height difference by using math.abs, and we're going to get the target ray.position.y and minus it by our self ray.position.y. And then that distance, if that distance is greater than our jump ability, then we know that it's too high and we shouldn't be chasing them. So we're just going to return true, saying that we need a path. So the first way that we're going to implement the should pathfind is, well, first I'm going to delete this because we don't want to just see the raycast anymore. But when we find a new target and we decide, okay, the target is not the same target we've been chasing, we want to make sure that this new target that possibly we could chase isn't going to have to be pathfinded to. So I'm just going to put an if not self should pathfind, then we will chase them. So if we found an easier, closer target and we don't have to pathfind to them, then we should just chase them instead. And the other case, if we're still chasing our same target, but our target now, let's say they jumped over something that our NPC has to pathfind to get to them now, we want to check to see if self should pathfind and then our target. And if they should, then we need to self debug, switching to pathfinding, and we're also going to return self pathfind to and our target. So our target, if they jumped over something, if we need to pathfind to them, then we'll just pathfind to them by switching to that. And we also need to change our pathfind to script, because if we were to start switching pathfinding after we realized they needed to be pathfinded to, then this script would run, it would go all the way down here, and it would just immediately go right back to chasing because it thinks they can chase them. So what we would need to do is I'll first make a variable should pathfind to, and that's going to equal self should pathfind target. And if we should not pathfind to the target during our pathfinding and we realize we can just chase him instead and that'd be easier, we'll just do that. So even though we're not completely done yet, we can test a version of this out. So I'm going to play the game, let the NPC see me, and he's going to start chasing me, but I'm going to go up this little platform and I'm going to stand right here. He's going to decide that I'm too high up for him to chase me, so he'll switch to pathfinding and he'll go up here, but he actually might not go up here because there's another issue we need to fix, but he will switch to pathfinding. So let me first be down here. He's going to see me. I go up. He decides, okay, I need to chase this guy. And he's going to try to get up, but Roblox pathfinding sucks and doesn't tell him to jump, so that's the next issue we're going to fix, so he'll actually get up here. So how we're going to fix this is we're going to create an auto jump for our character. So inside of the NPC class, I'm creating a .touch connection on our root, and this connection is being stored under the auto jump connection. And we also have an auto jump DB, which is going to make it so we can't jump super fast, we won't be able to keep auto jumping really fast. But what we do is when we are hit, we're going to check to see if there was a hit, and we also didn't touch like another NPC or a humanoid, and we also want to make sure that we're not jumping too fast by minusing tick by the last time that we jumped, which would be just, we set it for right now. And so basically if this result is greater than 1 second, which means it's been longer than a second since we've jumped, that means we can jump again. So if that happens, we're just going to self.humanoid.jump equals true, and it's going to make our character jump, which should fix all the issues, which testing it a lot, this fixes most of the issues that happens when Roblox doesn't tell the NPC to jump. But with that added, we're going to test it again. We're going to go right here. We're going to play. He's going to see us. I'm going to go up here and quickly go up. He detects, okay, I need to start following him instead, and his root will touch that, so it'll make him jump. We'll do it again, and he chases us, and he's up here now. But there is still another issue with the deciding if he needs to be pathfinding or not. So he does detect if someone is higher or lower than him, but there's still going to be an issue if you're the same height or altitude as him, but there is nothing in his way. He's just going to think, oh, they're right there, they're not too high up, I can just walk instead. So he's just going to see us, he's going to immediately think he can just chase us, and he's going to walk right off the edge. How we're going to fix this is we're going to be doing another raycast, but detecting that what's in front of them, and it's basically going to be this NPC's way of deciding if he's going to fall off the edge or not. So we're going to code that into our should pathfind method. So we're first going to get our raycasted step by getting the origin, which is going to be our self position, but then we're also going to need it to move it a few studs of where we're going to be moving, so we can tell if there's anything going to be under us if we step forward. And so we're going to use cframe.lookat, and our starting position will be ourself, but then we're going to look at the target, and then with that we can get the look vector, and then we decide how many studs we want to see ahead of us. So there's a thing in here called self.step distance, which we need to make. So at the very top right here, I'll just put it right here. We'll do self.step distance, and right there we're going to equal this to, like, I think 3, because you can change it depending on the NPCs always, but 3 I think is a good number. But this will be our origin, and once we have our origin, we can just raycast using it, so we're checking a few studs ahead of us using the self down direction, and just giving our same raycast params because they work the same. And we also want to visualize it so we can see if the NPC thinks it can walk forward or not. So now that we've used the raycast, if the raycast failed and there wasn't anything underneath us, then we need to debug saying that the stepping ray has failed and that we need a path. And we also need to set the last step check to equal tick and return true, saying that we need a path. And this last step check is going to help us so we're not trying to see if we can walk forward too much, or else the NPC would just endlessly try to run off a cliff and then not, because it realizes it can't. So we're going to make sure we set this inside of our class. Right, we'll do it right here, and we'll just equal it to 0. And we also want to add another one, which is how often we can check to see our step. So I'm going to call it step check wait, and I'm going to equal this to 3 seconds, or I'll do 4. So they have 4 seconds before they can check their step again if they fail to check it. So if they're successfully checking their step and they can keep walking forward, then it's all good. But if they check their step and they're going to walk off a cliff, then we're not going to allow them to check their step until they've pathfinded just a little bit and hopefully got themselves back on course. And so right above this, right before we actually make our raycast, to check that if they're not raycasting their steps so much, we want to get tick and minus it by our last step check. And if the last time they raycasted their step is less than the amount of time that they need to wait, then we will deny their request and just say the raycasting step is too fast and that they need a path, and return true. And before we do test the updated method, there's something I completely forgot to do, and that's our path params inside of our pathfind2 method. This will determine like how the NPC pathfinds and how much spacing there's between the waypoints, or if the NPC can jump or not. And so I needed to add that, just completely forgot. So we're going to do pathfind, and we're going to do self.pathparams. It's just going to equal a table, and we can put whatever we want. So if we wanted to put waypoint spacing, we can equal that to like 1 stud, so that's pretty close together. makes it a little more accurate. We could do agent radius, so how much radius they have if they need to go around corners a little bit wider, and we'll just do like 3. And I think there's also one similar, it's like agent width, so we'll do that. Whoa, agent width. And then also there's one if our NPC can jump or not, so we'll do agent can jump, and we'll equal that to true, and this will give us a little better control to how the path is calculated. But with this setup, we can go ahead and test it out. And I also wanted to just update this update tick just to be a little bit faster, and also make the step check wait just a little sooner. And now that we're working with some unlevel ground, this line of code, this little piece right here, can work for making things more smooth on flat surfaces, but this might tell the NPC that it needs to walk off a ledge before it can start its path. So I'm going to remove it because the terrain's a little different, and I'm also going to, because the NPC sometimes thinks it can't go places when it can, I'm just going to make these a little bit smaller so it knows it can go those places. And also when we're deciding if they should be pathfinded to, I've noticed that some of the NPCs will just continue to walk even after we've decided they shouldn't chase anymore. So as soon as we know that the step ray failed, I just put a self.humanoid move to, and then we just move to our position, so they'll just freeze for a little bit. And then once we can decide where they need to go, they can start moving again. But I'm going to test it out now. So I have some different things, but I'll bring this for right here, and I'm going to play, and he's going to try to walk to me. He's going to fail, and then he's going to have to go around the other way. So he's going to keep going. He's going to keep checking to see if he can walk to me, but now he's just going to chase me. And I can go up the different things. He's going to chase and all that. It's also really important to make sure that your maps and your NPCs are configured to work with each other well, because if I were to have the NPC and his step check wait is like 2 or 3 or something, and there's a long stretch, he's going to see that I'm here and he's going to try to like walk over here, but then he'll see that he can't step down, so he'll walk back. But as he's walking back, like 2 seconds later, he'll see that I'm right here and then try to walk right back again. And so he'll endlessly just keep walking back and forth. We can kind of test this out. So if I'm here and he goes at me, he's going to walk, but then 3 seconds later, he's going to see that he can chase me again. And then it kind of just, it's a repeat. So you can either fix this by making your maps different, so you can shorten this so there's no way he's gonna like walk back and forth, or keep it the same distance but change this to like 5 seconds so he won't check his steps so often if there's like a lot of, you know, divots and things. So he'd go and he'll wait a while before checking his step again, and then it should be good. So one error that needs fixed is if the NPC loses sight of me and then decides to pathfind. If he regains sight of me and needs to pathfind to get to me quicker, he won't do that. He'll just keep following the same path, and we want him to switch paths if it's easier and closer to me, or if I've moved far away from the end point. So as an example, I'll also just slow him down real quick. So I'll go right here, and he's gonna pathfind to me, he's gonna see me, he's gonna lose sight of me and try to pathfind. But if I pop up right here, he should switch paths, but instead he's not. He's just gonna keep following this same long path, and then he'll re-pathfind to me. So the easier option would be here, but he's not doing that. So that's what we're gonna fix. So we've added just a little bit of code to our pathfind2 method. So if we see a target and our target is the same as this target we've been pathfinding to, and their distance is farther than 12 studs, so they're like farther than the endpoint, and it's probably just best if we recalculate, then we will recalculate by using our same method and pathfinding to the target again, and this should fix it. So we're gonna go test it out again. I'll go right here. It's gonna see me. It's gonna pathfind to me. It thinks this is the area, but if it regains sight of me in an easier area, it's gonna recalculate. So he sees me again, realizes it's way easier to just do this instead, and then he'll just follow me. So now we have set up all the logic for all the NPCs that we want to make, but now we want to just make the fighter and make his attacks and stuff. So while we're creating our Fighter Npc class, we're going to give a table called basic attacks. And in this table, we're going to have animation name, which is going to be the name of the animation that we want to play when we're doing the certain attack, the damage it's going to do, the debounce before we can use another attack or before we continue chasing. And then I also set a speed for the punch, because when I made the animation, the punch is a little slow, so I just wanted to increase the speed. So I just put a speed value in here so it speeds it up by half. And these attacks are just going to get chosen by random, so randomly we'll punch and kick. And now we need to update our attack method, and I'm going to give it the argument of target, and I'm also going to then get our target root, our fighter position, and then we're going to choose an attack from our basic attacks, just doing math.random with however many attacks we have. And then we need to play that animation, so we have our animation, which is going to be the animation that's inside of our humanoid, and we got to make sure that we name our animation names the exact same that's in our humanoid, because that's how we find it. So we get that humanoid, we get that animation from the animator, we get the track, we load up the animation and stuff, and then we play it, and we adjust the speed to if there is a chosen speed or just 1 by default. And before we continue our script, we want to make sure that we get that hit signal that is triggered by our animation, so we won't do damage until we hit them. And then we're going to sit our humanoid down, because what I want to do is apply some force to our model, and so I don't want the character being able to move while that's happening, so we just enable sit. We also get this hit variable because we're going to check to see if we can damage the player 2 times, and we don't want to damage them more than once, so this is just going to help us do that. Then we're going to have our force and up direction, which this is the amount of force that our user is going to experience when they're doing an attack, and the up direction that they're gonna have. So for our kick, I want the fighter to kind of fly through the air. And specifically for our kick attack, we're going to have our force be 135 and our up direction be 8. So if the NPC decides to kick, it's going to go kind of flying in the air. And then if it's not, if it's just our punch, we're just going to have this much force with this much up direction. And then we need to calculate the force direction that's going to be on our user's root part. So we use cframe.lookAt, and our position that we're starting from is our position. And then we want to be looking at our target's position. But then we're also going to add that up direction by doing vector3.y-axis and then timesing it by however much we want to be looking up. And then we just get the direction, and then we apply that direction plus the force we want to have to our humanoid root part. So we'll kind of go flying in the air if we're kicking, or we'll just go move a little forward if we're just doing a punch. So now for inflicting the damage, there's multiple ways we could do this. If we wanted to, we could see if our leg or if our arm gets touched, and we could do damage to whatever touched it as punching. But the way I'm going to do it is we're basically going to inflict damage 2 different times. We're going to inflict damage the first time this gets triggered, and then also right after the animation ends. So we're going to do this with a for loop, and what we're going to do is we're going to check to see if there is no hit, because we don't want to damage them twice. We want to make sure that our target root exists and the distance to them is in our area. And if it is, then we're going to do our damage. But if not, then we're going to make sure that we're on the first iteration. And if we are, we're going to wait till our animation ends, and then we're going to do that one more time. So this is going to run twice, at the very beginning of when this gets triggered and at the end of the animation. And then when we actually are doing damage, we're going to make the hit equal to true, so we don't damage them twice. We're going to inflict damage on them with our chosen attack damage. And then if our animation name, if the attack basically is the kick attack, then we're going to make the target sit, because I want the kick to kind of stun our target just a little bit. It's not going to be that much of a stun because the player can just get back up, but it's something different for our kick. And then we're just ending our attack by waiting our debounce time and then setting our sit equal to false. And also some code that needs added is we want to make sure that we freeze our player up here by setting their humanoid walk speed to 0, and then we reset the speed back to their original speed by doing self.walk speed. And we need to make sure that self.walk speed is set in our NPC. So right here, I'll do self.walk speed equals self.humanoid.walk speed. So then we'll have a default walk speed. So I do want to add another function to him where he'll basically look at us while he's making his attack, so it looks better than just him staring off to where we originally were. But we can test it right now. He just won't look at us, but everything will work as it should. So you'll see that he's gonna attack me, he's gonna kick, and he kicks me down, and then he's punching me, and he's done all that. But you can see that if I'm walking behind him, if he starts attacking, but then I walk behind him, he just doesn't really look at me while he's making his attack, so I want to add that as a feature. So we're going to be able to make our NPC look at us while he's making his attack by creating 2 new methods in our NPC class, which is start aiming and stop aim. And the start aiming method is going to have our target, and we're going to make a few variables, which is going to be, one is going to be cframe.lookAt and vector3. And I'm just making these into variables because we're going to be using them a lot in a loop, and it's just better if we make them local. And to actually make our NPC look at the target, we're going to create a heartbeat connection on run service, which we need to add at the very top of our script. So do local run service get service run service and put that right there. And so we use run service, and we're going to put that in an aim connection inside of ourself. We're going to get the fighter position, which is us, and then we're going to make sure that the target we're aiming at is still alive. So if they're not alive, then we're going to use our stop aim method and just return. But if they're alive, we need to get the look at position, which this is just going to be vector 3, and we're going to be aiming at their X and their Z axis, but not the Y axis, because we don't want our fighter looking up and down all weird. We just want them looking left and right. And then we're also going to plus the humanoid move direction, because if they're moving a little bit, then we just want to aim where they are. And then we actually need to set our C frame, so we do self.humanoid root part C frame is equal to itself, and then we're lerping it. And what lerping does, it's just setting a value by a percentage. So if you were going to move 10 studs up, if you were to just lerp it by 0.5, you're only going to move 5 studs up. So we're going to be lerping with our cframe.lookat, starting with our fighter position and looking at our look at position, and then we're only going to be turning at them by 20%. So if you made this a lower number, then you would be turning slower, and if you made it a higher number, you'd be turning a lot faster. This just keeps it kind of smoother. And for our stop aim method, we just check to see if we have an aim connection, and if we do, we disconnect it and we set it to nil. So now we can use these methods. So in our fighter, we'll do self, and then we can do start aiming, and then we'll give our target. After we are going to hit, we should do self and then stop aim. So right after we're about to fly in the air, we don't need to be looking at them anymore. And I'm also going to set the speed of our attack speed really slow, just so we can see the aiming happening. So we're going to test him out, and he's going to be really slow when attacking us. He's trying to find us. I'll actually jump over here, but he's walking to us. He's going to punch us. He's really slow, and he just jumped off the edge, so I'll have to come down here. But he's going to chase us. You can see his attack. He's punching us really slow, and he kind of jumps in the air. You can also see if he does his kick. No, he's only punching right now. Okay, he's going to fly through the air and probably knock me down too. Yeah, the animation's so slow that the damage comes after. That's why you want the animations to be a good speed, so it doesn't look all awkward, but it's pretty slow right now. So I'm actually going to increase that. We're going to go to our fighter. I'll decrease this and set the speed to our punch to the good speed. And I also will increase our fighter's speed. Okay, there we go. He's kind of fast. He's chasing us. He's kicking us, trying to punch us. We're dodging him. And he's flying through the air with his kicks. Try to juke him out. No, he's too fast. But yeah, that's the NPC. I really want to make more NPCs if you guys want more NPCs. And if you want tutorials on like different types of fighters and stuff, or like maybe different enemies, I would love to do that. So just leave those in the comments below. Thank you for watching this video, and huge shout out to all the supporters on the Patreon: Jim Barry, It's Isaiah, Drew Chabu, R. Jackson, Bradley's World, Raul, Wesley Kramer, Dennis Bender, David Mursky, D. Sari, Eneko Ruiz, Giselle, Luckman, Rashad.